Hello, today we are talking about families of functions. So before we start, I have a picture of some families up here. So I want you to think and reflect for a minute on some characteristics or traits, things you have in common with your family. For me, some of the things I have in common with my family are that we all went to school in Cambridge. A couple other things that we have in common is that we love pizza. A couple other things that we have in common is that me and all of my siblings all have brown eyes and we all have brown hair. So these are just a couple characteristics of things that we have in common. Me and my family do. So think about things that you might have in common with your family. My family, we're also different. We have things that are different from each other. For example, my brothers are taller than me, and my sister is shorter than me. And those types of things. So we have similarities and we have differences. Today we are going to be comparing graphs and talking about their similarities and their differences. So first, we are going to graph linear functions. So we have function notation, function meaning function form or solve for y. And we already know how to solve for y. This is our equation that we've been working with, y equals mx plus b. Well, now, instead of putting a y here, they're going to try and trick you by putting a function. This is called function notation, that f of x right there. This is just a big fancy way of saying y. It's really just a y, you guys. So anytime you see f of x, I'm going to just cross it off and put a y there instead. So I like to think of f of x, like I said, a fancy way of saying y. So maybe it's all dressed up. It's got its tuxedo on, or its suit and tie, or its fancy dress. It's all disguised, but it's really just a y, all underneath, okay? So our key concept for today is we are going to compare all of our graphs to what we call a parent function. Just like I would compare myself to my parents and their accomplishments, or to their height, or what they look like. And that's what people in our generation tend to do. When you have a child, they say, oh, they look just like you. They have the same characteristics, they have the same eyes, they have the same ears, whatever. So we're always going to be comparing to what's called our parent function. This is the most basic linear function in all the family of functions. And this is f of x equals x. Well, we just learned up here, f of x is just a fancy way of saying y. So we really have the equation y equals x. Well, we know this is really a 1x. And we also learned last time that if there's nothing there for b, it would be plus 0. So we know our m in this equation, or our slope, is 1, or 1 over 1, and b is 0. Reminder that b is our y-intercept, or where we're crossing the y-axis. So our parent function, this will never change. It will always be y equals x, or y equals 1x plus 0. It will always begin at 0, and move or have a slope of rise 1, run 1, rise 1, run 1. And as you can see, that is the exact line that they created. Or we could go down 1 and 1 to the left. So this is the line that we're going to compare to. They like to label it f of x to tell you, hey, this is the fancy parent function right here that we're going to compare to. So here is our parent function, this f line, or f of x, whichever you like to call it. And they want us to compare our g function, or line g, to line f. I like to think of line f as just naming it. This is Fred. My grandpa's name is Fred. It really is. His name is Fred. So we're going to compare, let's say, Gina to Fred. So we are going to compare our slopes, m, and we are going to compare b, our y-intercepts. So B is our y-intercept. I'm going to shorten it. So first, we need to compare the new Gina, young Gina, to old Fred. Okay? So our slopes. We need to look at them, and if they are the exact same angle, we can say that they have the same slope. Another word for that, some of you might know, is parallel. So down here, if you want to use the word parallel, you can. Otherwise, you could say same slope. And you can pick either one of these. You don't have to write both. Okay? So our slopes are the same. Our B is our y-intercept, where we're crossing the y-axis. So I'm going to highlight our y-axis here for a second and take a look at it. Does Fred cross the y-axis at the same spot that Gina does? Well, no, they cross in two separate different points. So I'm going to say that they have different y-intercepts. So they have different y-intercepts, but you guys, if something's different, we need to say, how is it different? So what we've been doing really is you're going to tell me if something is the same or if it's different. But if it's different, you need to tell me, how is it different? Okay? So I have different y-intercepts. We're always comparing to old Fred. Fred's right here, but Gina's new, young Gina, we're going to compare Fred to Gina. Gina has really moved up 1, 2, 3 units, or 3 squares. So we're just going to say moved up 3. What your MCA or the book might say is a vertical translation. That's the same as saying moved up so many. Moved up or down. I'm going to just put up or down. Because it could be either. The line could have been below Fred and then it would be moved down. Alright, so that was our first problem, comparing M and B. Now we're going to do the same thing with these two lines. We're going to compare Fred to Gina. So here's Fred, and here's Gina. So first, Fred, our slopes. Do these slopes look exactly the same or parallel? To me, they don't. And if you're not sure, I like to use the analogy or think of sledding. If I am going to go sledding, are these hills going to be the same? Well, of course not. The hill that Gina's sledding down is a lot steeper than the hill that Fred is sledding down. So first, I would just, I would say, hey, well, the slopes are different. Remember? Tell me if it's the same or different. So we have first, different slopes. And reminder, if they're different, you need to tell me how they are different. So, like I said, if we're going sledding, you can think of a fast hill. If we're going sledding really fast, that must be a really steep hill, so you could use the word steep or fast. Either one of these mean the same thing. Or if this hill is slower, a flatter hill, a flat hill will be very slow. But reminder, we're always comparing Gina to Fred. So Gina, that hill is a lot steeper. So the steeper slope. Or you could have used the word faster, because you're going to go sledding down that hill faster than you would sled down Fred's hill. Okay? So that's our slope, M. Now B, our y-intercept. Do we cross the y-axis at the same point or at different points? Well, both of them cross at exactly the same spot right there, so we can just write same y-intercept. Alright, third one right here. Here's Fred, and here's Gina. First, we're going to compare M, which is our slope. So these hills, if we're going to go sledding down these hills, the hill I'm sledding down Fred's sledding down, It's going to go pretty fast. And then if I go down Gina's hill, not quite as fast. Can you tell it's a little bit closer to the x-axis? So I'm going to say that they have different slopes. I shortened the word different to D-I-F-F. And if it's different, you can tell me how. Well, Gina's hill is a flatter hill, or a flatter slope, or you could put slower slope. And then we also need to compare B, or our y-intercepts. So first, one thing before we go on, we didn't talk about one thing down here which is called reflection. If you look in the mirror, you see your reflection. You see yourself right back. But it's the opposite. Okay? Because if you lift your right hand up in the mirror, it's going to show your left hand in the reflection. So a reflection would just be the opposite, or one is negative. So if we look at our hills here, thinking back to our slope, this hill, if I was going to walk down, would be going downhill, sledding down there. But remember, we really read slope from left to right, so this hill would be going uphill. So this is what's called a reflection. I like to think that our slopes, if we're going to go sledding, our people are going to collide. It's not going to work because Gina and Fred are sledding in different directions. The hills are reflected or flipped across the y-axis here. They're flip-flopped. It's reflected, just like you would see in the mirror. So then last, our y-intercept, B. These two actually do cross the y-axis at the same point. Because here's our y-axis. They both cross right there in the middle. Oops, I need a pen. Right there in the middle, so they have the same y-intercept. Alright, these words down here again are just words that are going to help us compare M and B. So now we need to graph a couple on our own. I was nice and graphed our parent function for us. Remember, our parent function is right here, f of x equals x, or really y equals x, or 1x plus 0. And I graphed it. I began the graph at 0 and had the slope 1 over 1. Rise 1, run 1. So I graphed that line already on both, because we always have to compare to Fred. Fred does not ever change. Okay? We could go this way too. I'm not going to put all the points on there. But we need to compare it to our new graph, Gina, or here's maybe Peter. Okay? Those are our new graphs that we need to compare to. So first I'm going to graph Gina. This is really a y. So we have y equals x, or 1x, plus 7. So our m, or our slope from the equation, y equals mx plus b, m is 1, and b is 7. So begin our graph at 7 on my y-axis, up 1, 2, 3, 4, 5, 6, 7. And my slope is 1 over 1. I can't go up and to the right, so I can go the opposite of up and right, which is down and left. Down 1, 1 to the left. Down 1, 1 to the left. And then draw your line through. And I'm going to put a G here, for this is Gina's graph. And then last, we just need to compare. Because they say this word compare, we need to compare two things. We need to compare M, and we need to compare B, our slope and our y-intercept. So first, do these have the same slope? You can look at the equations. Here's M, and here's M. Or you can look to see if they're parallel. And yes, these are parallel, and they both have a slope of 1, so we can write same slope. And if you want, you can write parallel. Reminder that we need to find out if M and B are the same or different. But if it's different, we need to say how it's different. And then B. where do we cross the y-axis? So here's my highlighter, my y-axis, oops, right there. So my y-axis, this one crosses right here, and this one crosses way up here. So I know right away they're crossing at different points. So different y-intercepts. And if it's different, we need to say how it's different. Our new graph Gina compared to old Fred is moved up 1, 2, 3, 4, 5, 6, 7. Moved up 7. You can say moved up, shifted up, translated up. They all mean the same thing. And we're done with that. Let's graph our second line over here. Again, I'm just going to call this one Peter. This is P of X. It doesn't matter. It's a fancy way of saying Y. And I just put the negative up with the top number. You need it with one, but not both. So this is the form y equals mx plus b, so we know b is a 0. So our slope is negative 1 over 4, and b, just like we said, is 0. So we're beginning at 0. And our slope is negative 1, so that means down 1, and positive 4 is to the right. So as far as we can go, so instead of going down and right, I can also go up 1 and to the left 4. And put my line through there. And I'm going to put my arrows on the end. So I'm going to put a P by this one because this is for Peter. And this was f of x, or Fred here, our parent function. Fred doesn't change, he's always the same. So let's compare m and b. Our m, or our slope, you can look just from our equations or at the graphs. This one was negative 1/4, and our parent function is just 1. You can also see that they're not parallel. So this has different different slopes. If something's different, reminder, we need to say how it's different. So think about sledding. If we're always going to go sledding down Fred's hill, and then we go sledding down Peter's hill, well, Peter's hill is pretty flat. So I'm going to say Peter has a flatter slope. But if Fred and Peter are both going to go sledding, they're going to run into each other. So we also have to add that one word. It's a reflection. It's flipped over. It's the wrong direction. Hill's going the wrong way. And then last, B. Where do we cross the y-axis? They both cross right in the middle at 0, so we can just say same y-intercept. Alright, the last two, same as the last previous ones, we just have to graph them ourselves. So let's graph this parent function on both. Reminder that f of x is just y, fancy way of saying y, so we have y equals x, or 1x plus nothing, in the form y equals mx plus b. So we're going to begin at 0. And this is, you guys, just part of the directions. So we're graphing this on both lines, or both graphs. So we can do it at the same time. We're starting or beginning at 0, and on both. And then our slope is 1, or as a fraction, 1 over 1. So rise 1, run 1. Rise 1, run 1. Up 1, 1 to the right. Or we could also go, instead of up and right, we could go down and left. And I'm going to draw my line through there. And put arrows on the end, and I'm going to label that with f, that's my parent function, Fred. And same thing over here, slope, rise 1, run 1. Rise 1, run 1. And then down 1, 1 to the left. This is one that you could memorize because it's the same graph we're going to graph over and over and over again. So I'm going to label it as well. You don't have to write Fred, you can just put F. And then we need to compare it to the graph that they give us. Here's p of x, or just y, and then we have 1/3 x plus nothing, or plus 0. So we know m is 1/3 and b is 0. So we're beginning at 0 in the origin, and then our slope is rise over run. Rise up 1, and to the right 1, 2, 3. Put a dot, and again up 1, and over 1, 2, 3. Instead of going up and right this direction, we could also go down 1 and 3 to the left, down 1, 3 to the left, and draw our line this direction as well. So now we need to compare two things. We need to compare m, and we need to compare b. So this line was really p of x. Maybe this is Paul. So first, comparing our slopes. Do these have the same slope? You can look at the equation, or you can look at the graph. They're not parallel. They do not have the same slope, so we can say different slopes. But if something's different, we need to say how it's different. Remember, that's the tricky part. Think about sledding. If we're always going to go sledding down Fred's hill, and now we're going sledding down Paul's hill, well, Paul's hill is going to be really flat. Or you can say that it's going to be a slow hill to sled down. And then we also need to compare B, which is our y-intercept, where we cross the y-axis. So looking at our y-axis, these two lines both actually cross at the same point right here in the middle. So we can say that they have the same y-intercept. They cross the y-axis at the same spot. And then our second one, we need to graph this equation. Here's h of x, or just y. Y equals 1x minus 4. 4 is a fraction, 1 over 1. So I know my m in that equation is 1 over 1. And b is negative 4. So I'm going to begin my graph on my y-axis at negative 4. And my slope is rise 1, run 1. Rise 1, run 1. Up 1, 1 to the right. Or down 1, 1 to the left. And draw my line through it. So all I did was use my slope, rise over run, to create my line up and right, and down and left. And this was, what letter was that? H? So maybe this is, what's a name that starts with an H? Henry? Or Hua? Something like that. So if we're comparing these two, compare M and compare B. Our slopes, our M, they are the same. You can look here, 1 over 1, 1 over 1, or look at the graphs, they're parallel. Parallel, or you can write same slope. And then B, where do they cross the y-axis? Well, if you look at our y-intercepts, right here, oops, pen again. This one crosses at 0, and this one crosses down a little bit. So we can say that they are different y-intercepts. But if something's different, we need to say how that's different. We're always comparing to Fred, so Henry is moved down 1, 2, 3, 4 units. So I'm going to say moved down 4. There we go. If you have any questions, please make sure to ask. On the front side of your homework, M and B are what you need to compare, and the two lines are there for you. F, Fred, is always there, and then you always have to look to see which one is G, for Gina or George or whoever. On the back side, you have to graph both. Graph your parent function and the function they give you, and then compare M and B. This bottom part is just a review.